Okay, this is Algebra I Lesson 21. All right, we're going to talk today about the product rule for exponents and addition of like terms with exponents. Now, let's look at 3 to the 5th power. What does that mean? It means 3 times 3 times 3 times 3 times 3, yes? 3 to the 5th power. What does this mean? Okay, we know that 3 squared times 3 to the 3rd is what? 3 times 3 times 3 times 3 times 3. Yes? And we also know that this means 3 times 3 times 3 times 3 times 3. Do you see that? So we now, by looking at that, we see that when we multiply exponents whose bases are the same, remember we talked about the base is what? 3 and 2 and 3 are the exponents or the powers. We said when we multiply exponents with the same bases, we simply are adding. Look at this one. Isn't 3 to the 2nd, isn't that equal to 3 times 3 times 3 times 3 times 3? Or we could say this is 3 to the 5th power. Then we add those in here. Isn't that 3 to the 1, which is 3? 3 to the 4th is times 3 times 3 times 3. And isn't it the same thing as saying 3 to the 5th power? Then we add 1 and 4 to it? Yes. So, when we multiply exponents with the same base, we simply add the exponents together. And together, this gives us the product rule for exponents. If you look at page 92, the product rule for exponents says if m and n are real numbers and x cannot equal 0, then x to the m and x to the n times x to the n is equal to x to the m plus n. We said m and n have to be real numbers and x cannot equal 0. That is your product rule for exponents. Let's look at some examples. Let's look at example 21.1 and 21.2. It says we have x squared, y squared, x to the 5th, y cubed. Well, we have to have the same basis. Do we have any same bases? Yes, right here. If x squared, I can rearrange them to look like this. X squared times x to the 5th, if you add the exponents, it's 7. 2 plus 3 is 5. You simply have x to the 7th, y to the 5th. Okay, now we must define what x to the 1 is. X to the 1 is simply x. Okay? Or x is equal to x to the 1st power. So if there's a constant or a variable without an exponent, it's an implied 1. The exponent is understood to be 1. So 5 is equal to 5 to the 1st power, or 5. 7 to the 1st power is equal to 7, just like x to the 1 is equal to x. Okay, so let's simplify some other ones. Let's look at 21.3. We have x, y squared, x cubed. I'm going to rearrange them so I put my like bases together. And this x times x, this is an implied 1. I add my power rule says I add the exponents. 1 plus 3 is 4. X to the 4, y, this is implied 1. 1 plus 2, 3 equals x to the 4, y cubed. Simple as that. So let's look at 21.b. It talks about addition of like terms. We talked about what a term is. Term is separated by a plus or minus. And we said in order to combine like terms, they had to have the same variable or variables to the same power. Now we only looked at ones to the 1st power. Now let's look at one that's a little different. So let's look at this one. 3x squared plus 2x squared. We said we have two terms. In order to add them or combine them, they have to be like. So we ignore the constants or the number. We just pull down the variable on each one. They both have x squared. They have to have the same variable to the same power Then we just add the coefficients. 3, positive 3, and positive 2 is 5, and you keep it. It's not 5x to the 4th power. Okay? You have to keep the bases the same, and then you simply just add the coefficients or the constants, and you keep the base to be the same. All right? We said we kind of look at it as a denominator, a fraction. Kind of think of the variable or variables as the denominator, and then the constant as a numerator. In order to add these, the denominator or the variables have to be exactly the same, yes? Or you have to have a common denominator. Once they're the same, you simply add the numerators or add the coefficients. Though you can't, the terms aren't alike, you can't make them alike like you can a fraction to get a common denominator. But they're similar. They didn't say they're the same, they're similar. So let's look at another one. Let's look at example 21.5. So it says simplified x squared y p to the 5th plus, I'm going to have to pull my book up here, sorry about that, otherwise it's a long problem, plus 2xy squared p to the 5th plus 3p5x squared y minus 7y squared x p to the 5th. Okay? There's a little delay here. Sorry about that. Okay. So first of all, we have to see how many terms do we have in this number? We got 1, 2, 3, 4 terms. Remember I said pull down the exponent. This has a coefficient of what? If there's not a number or constant here, it's an implied 1. So I said bring it down. You have x squared y p. Here you have x y squared p squared. Here you have p squared x squared y, and you have here y squared x p to the 5th. Let's see, did I write that down? X squared y p to the 5th. X y squared p to the 5th. P to the 5th x squared y minus 7 y squared x to the 5th. It's kind of hard when you start having a bunch of different variables, different powers, to see are they really like terms. The best way to do is put them in alphabetical order. P x squared y. Remember to write this to say P x squared y. This becomes p to the 5th x y squared. This becomes p to the 5th x squared y. This becomes p to the 5th x y squared. Okay. I notice now I can see these two are exactly the same. What are the coefficients? Positive 2 and negative 7. So I simply, positive 2 and negative 7 gives me a negative 5, and I write it like this. Okay. Then I've got these two. Are these two the same? Oops. Yes, they are. They're exactly the same. So I can combine. Remember, there's not a constant or coefficient to imply 1. Positive 1 and a positive 3 is a plus 4 p squared, or p to the 5th x squared y. So once you have a lot of variables with different x, put them in alphabetical order. Then it's easier to see, okay, these have the same, both p to the 5th, both have an x, but that's square and y. They're not the same. Okay, let's see, is this one the same? Yes, yes. Oh, these are exactly the same. Okay, what about this one? First two are the same, that one's not, so that it's just these two. And then you can go back, and it's easier to look that way. That's the best way to do this. So, and again, in order to simplify, they have to have the like terms, same variable or variables to the same power. Even though these look like they're the same, they're not like terms. Because you both have p to the 5th, those are the same. You have an x squared here and an x. They're not to the same power, so they're not, there you go. There alone makes it a different term. So you need to do your review your practice problems for this lesson. And your code for this lesson is on the practice problem 21. I want you to show it to me when you pull it out when I say pull your practice problems out. And on the top of lesson 21, I want you to write pop quiz. Okay? If you do that, there's no pop quiz that day. Otherwise, there's a pop quiz. All right? Top of practice problems 21, the top of the page. That's it.